Hi, everybody. First things first. How many Brazilians do we have here today? Raise their hands. Nice. Em português, obrigado por estarem aqui. Vocês provavelmente já sabem um pouco sobre SiSU. For the non-Brazilians, have you heard about the SiSU? If not, no problem. We'll talk about it today. So, officially, good afternoon. My name is Maria Carolina, and I'm a Customer Solutions Manager for Government in AWS Brazil. Here with me are Alessandra and Makino. Please, introduce yourselves.
Hello, thanks for being here. It's a pleasure to be here. My name is Alessandra Faria, and I'm a Solutions Architect of Public Sector in Brazil.
Hi, everyone. My name is Ricardo Makino. I'm a Solutions Architect at AWS in Brazil Public Sector. And it's a pleasure to have you with us. Thank you.
Thank you. Well, we are excited to show you how we've helped the Ministry of Education to democratize the university access for more than 1 million students in Brazil. We also show you how our customer obsession and the power of AWS have made a meaningful impact in education in Brazil. So, let's go. Our agenda today, we will talk about what is MEC and SiSU, migration objectives, architecture and the load tests. We'll talk also about the AWS mechanisms, go-live challenges, results, and finally, the next steps. So, Ministry of Education, or Ministério da Educação in Portuguese, or MEC, is the main federal agency responsible for national education policies, evaluation, information, and national research. MEC manages the entire educational system, spanning from early childhood to higher education. Ministry of Education plays a vital role in setting the strategic direction for education in Brazil, working to ensure the quality and the accessibility of learning opportunities for all Brazilians. So, let's talk about the SiSU. SiSU, Unified Selection System, was implemented in 2010 by the Ministry of Education. It has changed the way that students can access public universities in Brazil. SiSU supports accessibility of access to higher education. It allows students from all over Brazil to apply to different universities nationwide without the need of travel to take the entrance exams. SiSU supports also the reduction of social disproportions. SiSU incorporates affirmative action policies, reserving a percentage of the spots for students from public schools, low-income families, racial minorities, etc. And the promotion of the quality of education. SiSU impacts the lives of millions of students every year. Given the importance and the large scale of this project, the decision was made to migrate to AWS to benefit from the power of the AWS cloud. So, let's talk about SiSU in a high level. First of all, students must take the NEM, the National High School Exam, held typically in November. After that, the students access the SiSU. Once inside the SiSU, they can apply up to options. They have the first option and the second option, allowing them to compete in 2 different courses or 2 different institutions at the same time. At the end, they are classified in a ranking according to their grades and the number of places available at each university program. This approach helps to ensure that selection process is transparent and accessible to all eligible students, regardless of their geographical location and socioeconomic status. So from the candidate's perspective, how SiSU works? Well, as I said before, the candidates can apply to a first and a second option. Different weights are applied to each course with minimum average and minimum grade requirements. For example, an engineer course might give more weight to maths course. After that, every course has its own cutoff scores or marks. And finally, SiSU will present to students his or her position and the options of the chosen courses, the final ranking. So, and now, how SiSU works from the MEC and the university perspective. And in scores, first of all, public universities publish their vacancies and the system. Students, they enter in the SiSU, and in scores are automatically linked in the SiSU. Students don't need to put manually the scores there. MEC process and returns the ranking, the final ranking, to the university with the students selected for the vacancies. It's important to say that during the process of this ranking, it's applied the quotas. As I said before, quotas for students from public schools, racial minorities, etc. And finally, after the selection process, universities use the SiSU management system to access a student registration that are able to enroll in the university. Now, let's talk about some numbers of SiSU. Since 2010, 15 million students passed in SiSU. And every edition, we have around 3 million students eligible to access the system. So now my friend Alessandra will present the migration objectives.
Thanks, Carol. So when a decision was made to migrate the SiSU infrastructure to the AWS cloud, we had 5 main objectives in mind. The first one is cost reduction. The second one is the return the management of the process to the MEC. At that moment, the process of the knowledge of the process was with a partner, and they wanted to have it back. Improve performance. Each year, SiSU have more candidates, so we needed to guarantee that the candidates would have a seamless experience. And supplier and component compatibility for a seamless integration, reducing the complexity and the risks associated with the critical event like Carol explained, and availability of support resource. We needed to ensure that we could count on a dedicated team of support in case of any incident. Now let's see the architecture in a high level. The SiSU architecture on the AWS cloud is designed to be highly scalable, secure, and reliable. At the core of the system is a virtual private cloud, or a VPC, and the services are deployed across multiple availability zones to ensure high availability and fault tolerance. On the front end, we have the Amazon Route 53 handling the DNS traffic, and Amazon CloudFront delivering the static content to users. Inside the VPC, we have a SQL Server database cluster, which stores the candidate data and ranking. The application is deployed on Amazon EC2 instance running Red Hat OpenShift, which provides a containerized and Kubernetes-managed environment. We have to handle the external integration and service, we have set up secure connection using AWS site-to-site VPN. At the AWS, security is a top priority, so we've implemented some security service in this architecture. As AWS WAF for web application firewall capabilities, Amazon Guard Duty for intelligent detection, AWS Security Hub for centralized security management, and AWS Shield Advanced for DDoS protection. For governance and monitoring, we have AWS config to audit and evaluate the resource, Amazon CloudWatch for logging and metrics, and AWS Trusted Advisors for best practices recommendation. Overall, this architecture leverages a wide range of AWS service to create a robust, scalable, and secure platform that can handle the high traffic and critical nature of the system. Now let's see how the accounts were organized. To ensure proper governance and control over the SiSU infrastructure, it was implemented a multi-account structure within the AWS organizations. At the top, we have the root OU, or organization unit, which serves as the entry point for the entire AWS environment. Under this, we have the management account, which is responsible for the centralized management of resources such as SSO, guardrails, and others. And we also have had specific accounts inside the SiSU OU. Dedicated accounts for backup, security, and logging to ensure the proper segregation of duties. And we also have the SiSU integration, the integration test environment, the SiSU UAT, the user acceptance test environment, the SiSU test, which is the standalone test environment, and the SiSU production, the main production environment for the SiSU platform. This governance structure allows us to maintain a high degree of control, visibility, and security over the resource, while also enabling the flexibility to manage different environments of the systems independently. Now, we will detail some of the services inside this architecture with my friend Makino.
Thanks, Ale. Just take some water. Well, as Alessandra said, at AWS, security is our top priority. And to secure the authentication and the authorization process is the first step into a defense in depth strategy. Because this is the first layer where threat actors will try to probe looking for misconfigured resources on your AWS environments. Using AWS Identity and Access Management, or just AWS IAM, we implemented a segregation of responsibilities and the least privileged principle to manage SiSU. At the core of the architecture, we have roles here. The roles are used to grant the necessary permissions into specific policies for different types of users. For example, database administrators, site reliability engineers, security analysts, or automation services. When a person needs to access the AWS console or AWS CLI, the first step is to provide the credentials, including the multi-factor authentication token. After the credentials has been validated, they assume a specific role with the right permissions to execute their duty inside the AWS environment. The whole AWS environment is managed using infrastructure as a code. Raise your hands, those who already use infrastructure as a code to manage your AWS environments, please. Awesome. It's a lot of hands. And for those who still do not use it, I recommend it because automation helps you to reduce errors, to deploy consistently across your AWS environments, and scale your teams because you can reuse the code from previous projects on new projects. On AWS, on SiSU, GitLab is the source of truth for all infrastructure code on our environments. When a site reliability engineer pushes a code to GitLab, it triggers our pipeline. When the pipeline is triggered, the GitLab CI runner starts to run, authenticates on AWS with secret key and access key, and then the GitLab CI runner assumes a role with high privilege to deploy the resources on the AWS. To create another layer of security on this high privileged role, we added a IP restriction as a condition inside the role. So just the IPs from GitLab CI runner can assume this high privileged role. And by leveraging the robust capabilities of AWS IAM, we created a secure and auditable authentication and authorization process to manage SiSU with the principles of least privilege and defense in depth. As Carol said in the beginning of the presentation, SiSU is the main way that students apply to public universities in Brazil. And it brings high visibility to the system, for good and for bad users. Raise your hand those who knows what is a distribution denial of service is, please. Great. For those that didn't raise your hand, a distributed denial of service is a type of attack which multiple compromised systems across the internet, with multiple computers across the internet, usually controlled by a single attacker, trying to flood some system or networks to overwhelm their resources and making it difficult for legitimate users to access this application. Understanding the nature of the DDoS attacks helped us to deploy the right protective guardrails on SiSU architecture. And how do we protect resources from the DDoS on events on the AWS? To prevent disruptions during SiSU event caused by DDoS, we used AWS Shield Advanced. AWS Shield Advanced is a managed service that helps you to protect against external threats from your environment, like DDoS attacks, volumetric bots, or web application threats like SQL injection or others. AWS Shield Advanced works together with AWS WAF to detect and mitigate attacks automatically. AWS Shield Advanced protect resources like Amazon Route 53 hosted zones, Amazon CloudFront distributions, Amazon Global accelerators, Elastic Load Balancer, network load balancers, and application load balancers, and Elastic IPs attached to AWS resources like EC2, for example. With AWS Shield Advanced, you have automatic L7 attack mitigation, as I said. Additionally, you have cost protection. It's not working, the laser point anymore. You have cost protection scaling during attacks. For example, if your application scales during a DDoS event, the machines, for example, if you use EC2, the machines that needs to scale to absorb the attack could be waived from your billing in the end of the month. Another great thing from AWS Shield Advanced is to have access to Shield Response Team. Shield Response Team is a team of security engineers specialized in DDoS event response. To protect SiSU perimeter, we used all resources except Global Accelerator and Firewall Manager. Let's deep dive a little bit more on the AWS perimeter protection and SiSU perimeter protection. At the edge of SiSU architecture, we have Amazon Route 53 to solve DNS requests, both for the front end and for the APIs. Additionally, we have two CloudFront distributions. The first one for the front-end static content, and the second one for the APIs. For the APIs, the requests are sent to a network load balancer and then to the APIs inside the OpenShift cluster. Additionally, on CloudFront distributions, we have AWS WAF to protect both the front-end and the APIs from web attacks. As I said, we have Shield Advanced protecting all edge resources on our architecture. And to complement the services, we have Amazon CloudWatch to monitor metrics and logs to detect anomalies or potential DDoS events on our environment. Additionally, the CloudWatch metrics and logs are closely integrated with the customer incident response process to help them to quickly identify and mitigate any security event or any disruption on the application. By layering these security services, we created a comprehensive perimeter protection strategy that helps ensure that SiSU remains secure and available for millions of students in Brazil. Detection and incident response to threats is a critical aspect of our defense in depth strategy too. We implemented a comprehensive set of services to collect and analyze events from multiple sources, automate tasks, and consolidate security issues and events to increase the operational efficiency on the SiSU team. As I already said, we have Shield Advanced, but to improve our event response, or detection and incident response, we created a Amazon CloudWatch alarm that sends a notification to a SNS topic and trigger two Lambda functions. The first Lambda function is responsible to engage the security operation team of SiSU during any kind of event or anomaly. The second one is a Lambda function to engage Shield response team during any kind of anomaly or issue during the event. And additionally, we leverage data from Amazon Guarduddy, AWS Trust Advisor, and AWS Config to look for threats inside our architecture or for misconfigured resources that could lead to a security issue on SiSU. All findings are centralized on AWS Security Hub, and then they are consolidated with Prowler, an open source tool that performs security best practice assessments on AWS. After that, all findings are sent to Defect Dojo. Defect Dojo is an application security posture management, which is used by the customer to track issues and create an action plan to mitigate these risks inside the SiSU architecture. By combining the power of AWS security services, open source tools, and the customer incident response process, we create a robust detection incident response mechanism for SiSU. Continuing our deep dive on SiSU architecture, here we have how the application runs inside the OpenShift cluster. And we have the guy that created this image for us here. At the top of the architecture, we have a network load balancer, which is the entry point for the OpenShift cluster. After the request has been received by the network load balancer, it sends it to the ingress controller router pods. The ingress controller router pods are responsible to route the request inside the cluster to the right service or the right deployment inside the OpenShift cluster. For SiSU, we have 2 projects or 2 applications inside the cluster. The first one is Project SiSU. SiSU is a portal that students can access to look for vacancies before the event starts. The first layer is an inbound API gateway that we use Kong for this. The second one is the application itself. And the third one is a data grid that is an in-memory cache developed by Red Hat. The second application is SiSU Aluno. SiSU Aluno is the API where students apply to vacancies and look for the results from the ranking. In the same way that we have on Project SiSU, we have an inbound API gateway, but the application is split into 2 deployments. The first deployment is for read requests, and the second one is for write requests. And the API gateway is responsible to route the requests to the right deployment inside the cluster. In the same way that we have on SiSU project, we have a data grid too, to store database that is the cache for database queries. And additionally, we have an outbound API gateway. This outbound API gateway was used to create a connection pool between the application, the SiSU API, that communicates with external APIs using HTTPS with TLS encryption. This helped us to reduce in 150 milliseconds per request because Kong maintains a connection pool between the Kong and the external APIs. But we know that architecture and plan is very important, but we have to test everything that we plan, that we architect, and that we develop. Before SiSU goes live, we conduct a comprehensive set of performance and load tests to ensure that the robustness of the system and the ability to handle the expected traffic and volume seamlessly. And to achieve these objectives, we conducted 4 different test scenarios, each one designed to simulate diverse user patterns inside the application. This approach allowed us to evaluate the system performance under a wide range of real-world scenarios. Our test results exceeded our expectations, even during peak load scenarios with 20,000 requests per second engaging in active transactions, even with 150,000 users in the same time engaging in the system. The API latency stays well below the 1 second. That was the requirement that the Ministry of Education gave it to us. The API rate failure was 0, demonstrating the system resilience and fault tolerance. And this achievement gave us confidence that SiSU would be capable of handling the expected traffic during the go-live event. But we know that even with a great work from all teams involved on the SiSU architecture and deploying, we know that can always be a point of failure. And as our CTO, Werner Vogel, says, everything fails all the time. And to mitigate possible failures that the team didn't see during the deployment phase or the architecture phase, we used some AWS mechanisms that my friend Alessandra will talk about for you.
Thank you. Probably you have already heard this quote from our CEO, NHS. There is no compression algorithm for experience. This quote tells us about the importance of designing and planning rather than trying to take shortcuts when building solutions. This principle has very much guided our approach for the SiSU migration. With a critical system like SiSU, we knew we couldn't afford to cut corners or rush the process. We had to carefully design the architecture, test it massively, and prepare for any potential challenges. That's why we put so much emphasis on performance and load testing we conducted before the SiSU launch. We didn't just want to hope the SiSU would be successful. We needed to guarantee that, and especially simulating the user traffic and the high traffic, and the user patterns. By doing this upfront work, we were able to identify potential bottlenecks and vulnerabilities and make the necessary adjustment throughout the project to deliver a seamless experience for the candidates in Brazil. This brings me to the next topic I'd like to show you, which is a framework we call AWS Countdown, a process we used before the execution of the SiSU. AWS uses a framework called AWS Countdown, previously called IEM, to ensure alignment and proper governance, proper planning, for large-scale events. This process includes planning, reviewing, risk mitigation, and a post-event recap. And we also use this process for events like Amazon Prime Day, when we see a significant increase in traffic and online shopping activities at Amazon.com. By following this structured approach, we were able to anticipate and address potential challenges before the SiSU launch, ensuring a softer go-live experience. AWS Countdown helped us throughout the project, and it was developed by proven playbooks, using proven playbooks developed by AWS experts. And how is that timeline? As a result of running hundreds of AWS Countdown, AWS has established a framework which we follow in a phased manner throughout the course of a countdown engagement. The slide highlights each of those phases, and at a high level, the 4 phases of the countdown engagement are: initiate, where we request a countdown engagement with the event date and details in hand. That moment we had the Danilo Castro allocated with us, the account team. So it's introduction to the countdown. The planning phase, this is where we spend our time diving deep into the nature of the event, review the infrastructure, review the architecture, and identify and mitigate the risks, create runbooks, and review the service limits, this SLA. The execute phase, which is the main phase of the event, where we have the monitoring the infrastructure and the TAM coordinate the escalation if necessary. And we also have a review phase where we return to normal operations, analyze the main metrics, and also document lessons learned of the event for continuous improvement. You can see that we have the well-architected review here in the planning phase. And how do we do that? Creating technology solution is a lot like constructing a physical building. If the foundation is not solid, it may cause structural problems that can compromise the integrity and functionality and function of the building. We should use the 6 pillars of the well-architected framework when architecting technology solutions, and it will help you to produce stable and efficient systems. The 6 pillars are operational excellence, the ability to support development and operation of workloads effectively and continually to improve supporting process. Security, the ability to protect assets, data, and systems. Reliability, this pillar is about ensuring that your system can deal with failures and continue to operate as expected. So it's about building in redundancy and resilience to handle unexpected issues. Performance efficiency, this pillar is about optimizing the performance of the system to meet the needs of your users. So it's about using the right resource and technologies to ensure your system is fast and responsive. Cost optimization, this pillar is about ensuring that your system is not using unnecessary cost, unnecessary service, so you can maximize the value you get from the AWS cloud. And sustainability. This pillar is about ensuring that your system or environment is sustainable and has a minimal impact on the planet. I would like to ask a question. How many people here have already done an AWS well-architected review? Cool, nice. Anyone can review your workload or environment using the AWS well-architected tool available in the AWS console. It's recommended that we do that in a recurrent way so you can continuously improving your system or environment. Besides the well-architected framework and the AWS Countdown, we also used another mechanism that my friend Makino will explain now.
Thank you, Well, let's talk about another mechanism that we use that is shield response team fire drill. But first, who here is in the room how to know how to use a fire extinguisher? Raise your hand, please. Not so many people. And in the same way that we need to know how to use protective equipment, and we need to know if they are working as expected, we need to know how to use the solutions that we deploy on our architectures. And we need to know that if they are configured as expected and correctly. And what is the best way to learn how to use a fire extinguisher or to test if they are working as expected? Anyone knows? During a fire drill exercise. So, to ensure that AWS Shield Advanced was correctly configured and every team knows what to do in a case of a DDoS event, we used an AWS mechanism called Shield Fire Drill, which is a simulation of a DDoS attack to help to identify potential gaps in incident detection, notification, and response inside your AWS environment. For SiSU, the Shield Response team conducted the DDoS event simulation in partnership with SiSU security team. To do this, the SRT, the Shield Response team, inject attack data into CloudWatch DDoS metrics to trigger all the process of detection, notification, and response for DDoS events. During the fire drill exercise, we identified that the Lambda function that engaged this SRT was not configured properly. So this insight gave all the information that the SiSU security team needs to do the right configuration on the Lambda function to engage the SRT in case of a DDoS event. This mechanism allowed us to test our detection and response measures, ensuring that we are well prepared to handle DDoS events effectively during SiSU Go Live, that Alessandro will talk about for you now.
Thank you, Makino. The SiSU platform went live on 22 January of this year with a peak of over 104,000 candidate access with around 11,000 registrations per minute. While we had some unexpected issues, such as authentication failure with an external provider, it didn't stop us. The one-team approach of our dedicated professionals helped us to address the challenge and ensure a successful launch. The team was involved in a war room with all partners, AWS, customers, working throughout the 4 days to ensure the edition would be a success. Now let's see some of the results of this effort with Makino, and I promise this is the last time I call him.
Well, monitoring is crucial for the effective operation of any system, and for SiSU is not different. But not just monitoring the infrastructure and application metrics matter. It's equally important to monitor business-related data. After the end of the 4-day SiSU that happened in January of this year, out of 2.2 million eligible students, more than 1.4 million students made over 2.4 million registrations to apply to more than 260,000 vacancies across 107 universities across the entire Brazil. These numbers highlight the importance of SiSU on the lives of millions of students. And additionally, SiSU has zero downtime. Considering that the execution window of SiSU is just 4 days or 96 hours, if you have 1 hour of downtime, it represents more than 1% drop in SLA. Maintaining a stable and reliable platform, it was our priority. Because any disruptions or downtime could have a significant consequence for millions of students depending on SiSU to secure their academic aspirations in the future. Now, talking about future, let's see what are the next steps for SiSU on AWS with Carol.
Thank you, Makino. So, let's talk about the next steps. We plan for SiSU in the next editions. For example, review the well-architected framework. It's a good practice always to review your environment. One important question, have you revised your environment regularly? Another thing is improve operational efficiency through optimization and automation. Other thing is outscale implementation for OpenShift clusters and pods to handle the demand fluctuations. One thing is automation runbooks. And finally, modernizing the applications into microservices. These are some actions that we plan for the SiSU to be more robust and more reliable solution. Well, that's our story. I invite Makino and Alessandra again here with me. And thank you. Thank you for your time and attention today. If you have questions or you want to know more about our lessons learned, please feel free to reach out to us. We are happy to provide you more details and information. And please, don't forget to complete the survey in the mobile app. Thank you.
Thank you.
Thank you.